Chapter 8, Section 8. Objective, learn to calculate surface area. And our central question, how do I find the surface area of pyramids and cones? Vocabulary, slant height, regular pyramid, and right cone. Let's look at those terms more closely. The slant height of a pyramid or cone is measured along its lateral surface. That means it's measured on the outside. The base of a regular pyramid is a regular polygon, and the lateral faces are all congruent. In a right cone, a line perpendicular to the base through the tip of the cone passes through the center of the base. Surface area formula for these two shapes is a little bit different than when we did it for prisms and cylinders. Because these only have one base, we don't multiply the base by 2, we just find the area of the base, and then we find half of the perimeter times the slant height. Now if you look at the cone, the formula is the same, only instead of perimeter, we're taking half of the circumference. So you'll notice the 1/2 disappears because 1/2 times 2 would cancel out. So it's just pi times radius times the slant height. So let's try to find the surface area to the nearest tenth using 3.14 for pi when necessary. So we have a rectangular pyramid. So the area of the base is 2.4 by 2.4 plus 1/2. The perimeter of the base would be 9.6, and our slant height, our outside height, is 3. We calculate those two values separately, add them together, we get 20.16 and 20.2 feet squared. For the cone, pi r squared, so 3 is the radius, plus pi times the radius times the slant height, which is L, which is the outside height. Multiply and add those together, we get 27 pi, or 84.8 centimeters squared. Let's look at another one. The area of this rectangular or square pyramid would be 3 times 3. Perimeter would be 12. Slant height is 5. Plug those values in. Multiply, add for 39 meters squared. For the cone, the radius is 7. The slant height is 18. Substitute the values in where appropriate. Multiply, add for 549.5 square feet. A cone has a diameter of 8 inches and a slant height of 3 inches. Explain whether tripling the slant height would have the same effect on the surface area as tripling the radius. Here's a table. We have the original dimensions. Then we have the dimensions where we've tripled the slant height. And the third box is where we've tripled the radius. So you can see our different values. They would not have the same effect. Tripling the radius would increase the surface area more than tripling the slant height because radius is located in 2 different places inside the formula. The upper portion of an hourglass is approximately an inverted cone with the given dimensions. What is the lateral surface area of the upper portion of the hourglass? We need the Pythagorean theorem this time because we don't have the outside slant height. We have the radius and we have a 90-degree angle in the middle of the right cone. So we plug in the values, 10 squared plus 24 squared. We add those together, take the square root, we get the slant height to be 26. The lateral surface area does not include the base. So we're just looking at the second part of the surface area formula, pi times r times the slant height. So that's pi times 10 times 26, which is 816.8 millimeters squared. So that's only the part around the cone. That would not include the base. A large road construction cone is almost a full cone. With the given dimensions, what is the lateral surface area of the cone? Same concept. Use the Pythagorean theorem to find that outside slant height. So we get 15. The lateral surface area does not include the base, so it's just pi times radius times slant height, which is 424.1 square inches. That's it. Make sure your notes are filled out completely. Use the formulas as you go through. It's just a plug in and figure out each part. On the left-hand side, write questions that could be answered from the material in your notes. Review your notes, eliminate extra material that you didn't need, and complete the summary before class.